Hello there, and welcome to the Sleep Whisperer. Tonight's voyage is just for you. There's nothing you need to do, nowhere you need to be. Just let the weight of the day dissolve. Allow your breathing to find a slow, deep rhythm, and feel the gentle release of gravity's pull, as if you're floating on a quiet, dark sea. Because tonight we're going to drift, not walk or run, through the silent, beautiful marvels of our cosmic neighborhood. We'll move in gentle, widening circles, from the sun's fiery embrace to the frozen, whispering edges where starlight is a memory. This isn't a story of cold numbers and harsh equations. It's a story of silent winters that last for decades, of volcanoes that weep ice, of magnetic melodies and lonely, tumbling rocks that sing a gravitational song. Every world, every moon, every speck of dust holds a secret, a piece of a puzzle that is both strange and deeply beautiful. We'll take it slowly, gently, one tranquil fact at a time. And just before we begin, if these quiet wanderings help you find a moment of peace or offer a gentle way to close your day, you can softly tap the like button and subscribe to the channel. It's a quiet way to help other wandering souls find their way to this calm. Now, let's begin. The solar system is mostly empty space. Size. It's easy to look at a diagram and see the planets clustered together, but the reality is a profound and calming emptiness. If you were to shrink the solar system to the size of a large city, the sun would be a small, glowing marble, and the planets would be scattered grains of sand, each separated by many silent, dark blocks. A spacecraft traveling through this vastness is a solitary soul in an immense, quiet cathedral. This emptiness isn't lonely, it's serene. It's the canvas upon which the planets paint their slow, graceful orbits. The sheer scale is a reminder of the peace that can be found in open, quiet spaces. Jupiter's moon, Io, is dotted with lakes of lava, while our moon is a silent, grey companion. Jupiter's moon Io is a world of fire and brimstone. It is the most volcanically active body in the entire solar system. Its surface a vibrant tapestry of yellows, oranges, and reds, painted by constantly erupting volcanoes and vast, simmering lakes of molten rock. Some of these lava lakes are larger than entire cities on Earth, their surfaces constantly churning. This incredible heat comes not from radioactive decay, as inside our planet, but from the constant, gravitational tug-zan of war between Jupiter and its other large moons. Io is squeezed and stretched, its interior flexing like a ball of clay in a giant's hand, generating immense friction and heat. It is a world perpetually remaking itself, a testament to the powerful unseen forces that shape silent worlds. Saturn's moon, Mimas, looks like the Death Star. Floating in the darkness around Saturn is a small, icy moon named Mimas. Its most striking feature is a colossal impact crater named Herschel, which stretches over a third of the moon's diameter. The impact that created Herschel came astonishingly close to shattering Mimas completely. The crater's central peak rises high from the floor, and from a distance, the moon bears an uncanny resemblance to the fictional Death Star from Star Wars. It is a frozen monument to a violent past, a reminder of the chaotic early days of the solar system, when such collisions were commonplace. Now, it orbits in silence, a peaceful, scarred sentinel. There is a volcano on Mars that is so wide, you wouldn't be able to see its summit from the base. Sun. We've already met Olympus Mons, the solar system's tallest volcano. But its sheer breadth is almost incomprehensible. It is a shield volcano, built from countless gentle lava flows over billions of years. Its base is so immense that if you were standing on it, the slope would be so gradual and the curvature of the planet so subtle that the summit would be hidden beyond the horizon. You could spend a lifetime walking its slopes and never feel you were climbing a mountain. It is a leviathan of geology, a quiet giant born from a world without shifting tectonic plates, where lava could pour from the same spot for eons. The sun's light is actually white, From our earthly perspective, filtered through the blanket of our atmosphere, the sun appears yellow. But in the pure blackness of space, the sun is a brilliant, stark white. Our atmosphere scatters the shorter, bluer wavelengths of light, leaving the longer, redder and yellow wavelengths to reach our eyes, painting our sky blue and our sun golden. The true color of the sun is the sum of all its visible light, a pure, clean white. It's a gentle correction to our perception, a reminder that the universe often holds a different, more fundamental truth than what we see from our single, precious point of view. Uranus smells like rotten eggs. While we can't ever visit the cloud tops of Uranus, spectroscopic observations from Earth have revealed a fascinating and rather unpleasant detail about its atmosphere. High in its blue Jan-green haze, hydrogen sulfide gas is present. This is the same gas that gives rotten eggs their distinctive, pungent odor. It's a small, almost humorous detail that grounds these distant, majestic giants in the realm of familiar, if unpleasant, sensations. Even in the grandeur of the solar system, there is a place that, if we could smell it, would make us wrinkle our noses. There is a world with a subsurface ocean that could contain more water than all of Earth's oceans combined. Europa's moon, Europa, often gets the attention for its hidden ocean, but it is another Jovian moon, Ganymede, that may hold the most water. Ganymede, the largest moon in the solar system, is thought to have a vast, salty ocean trapped between layers of ice deep beneath its crust. Scientists believe this subsurface sea could be dozens of miles deep, and its total water volume might exceed all the water in Earth's oceans. Imagine a world where the entire surface is a thick, frozen shell, and below it lies an abyssal, dark sea, utterly silent and unknown. It is a hidden reservoir of one of life's key ingredients, slumbering in the cold. Mercury is actually shrinking. For Mercury, the small, sun-scorched innermost planet, is slowly getting smaller as its massive iron core cools over billions of years. It solidifies and contracts. This causes the planet's single, rocky crust to crumple like the skin of a drying apple. All across its surface are visible long, sinuous cliffs called lobate scarps, which can be hundreds of miles long and over a mile high. These are the wrinkles of an aging world, evidence that even a planet close to the sun's fire is gradually cooling, settling, and shrinking in the quiet of space. Neptune's moon, Triton, has geysers that erupt nitrogen gas. Triton, Neptune's largest moon, is a bizarre and frigid world. It orbits backwards and is likely a captured dwarf planet from the Kuiper belt. Its surface is one of the coldest places in the solar system, coated in frozen nitrogen. Yet despite the deep cold, it is geologically active. When Triton's polar regions are exposed to the weak, distant sun, the frozen nitrogen on the surface turns directly into gas. This sublimation builds up pressure beneath the ice until it violently erupts, sending plumes of dark dust and nitrogen gas shooting miles into its thin atmosphere. It is a world so cold that its version of a volcano is a geyser of freezing gas, a silent, cryogenic eruption in the far darkness. The asteroid belt contains a dwarf planet that may be a protoplanet. V Ceres, the largest object in the asteroid belt between Mars and Jupiter, is a fascinating world, classified as a dwarf planet. It is massive enough for its own gravity to have pulled it into a spherical shape. Recent observations by the Dawn spacecraft suggest it is a protoplanet, a survivor from the solar system's earliest days that never grew into a full Jan-sized planet. It has a complex geology, with mysterious bright spots in its Akata crater, now known to be salt deposits left behind by briny water that seeped up from a subsurface reservoir in the recent past. Ceres is not just a rock, it is a fossil world, a preserved embryo of a planet that never was. Venus has continents. Beneath its thick, crushing, and toxic clouds, Venus has a varied and dramatic surface. It is not a uniform, hellish plain. There are vast highland regions that are considered continents, the largest of which is called Ishtar Terra, roughly the size of Australia. Another, Aphrodite Terra, is even larger, about half the size of Africa. These highlands are mountains and plateaus that rise above the lower volcanic plains. They are a reminder that Venus, for all its differences, shares a basic geological vocabulary with Earth, a language of highlands and lowlands written in lava and shaped by immense internal forces. Further is a space hurricane observed above Earth. In Launcendy, scientists analyzing satellite data discovered a previously unknown phenomenon, a giant, swirling mass of plasma hovering hundreds of miles above the North Pole. Unlike the auroras that dance in curtains of light, this was a stable, cyclone-gen-like structure with a calm eye at its center and spiral arms of plasma raining electrons down into the upper atmosphere. It was a space hurricane, a testament to the complex and dynamic interactions between the solar wind and Earth's magnetic field. It's a weather pattern, not of air and water, but of charged particles and magnetic forces, a silent storm raging in the void just above us. For the moon has a tail that points away from the sun. Our moon, seemingly so solid and solitary, has a faint ethereal tail invisible to our eyes. It is made of sodium atoms that are knocked off the lunar surface by the impact of micrometeorites and the pressure of sunlight. These atoms are pushed by solar radiation into a long, slender stream that always points away from the sun, like a comet's tail. Earth periodically passes through this faint, glowing sodium stream, which causes a slight, barely detectable brightening in the sky that can only be seen with sensitive instruments. Our closest companion has a ghostly flowing veil, a subtle connection to the solar wind that we pass through, unaware, several times each month. The Arprezen meteorites contain stardust older than the sun. Tiny microscopic grains found within certain primitive meteorites are not from our solar system. They are pre-gen solar grains, stardust that formed in the atmospheres of ancient stars that lived and died long before our sun was born. When those stars ended their lives in spectacular supernovae, or gently shed their outer layers, they seeded the surrounding gas cloud with these heavy elements. That cloud eventually collapsed to form our solar system. But these resilient dust grains survived the violence, becoming tiny time capsules. When you hold such a meteorite, you are holding literal pieces of other stars, the true ancestors of everything we see, including ourselves. Mars has blue sunsets. Hood. On Earth, our sunsets are red and orange because our atmosphere scatters the blue light away from our line of sight. On Mars, the opposite happens. The Martian atmosphere is very thin and filled with fine dust. This dust is the right size to scatter red light, allowing the blue light to pass through more directly. So, to an astronaut standing on Mars, the sky around the setting sun would glow a soft, ethereal blue, while the rest of the sky takes on a reddish hue. It's a beautiful inversion of our own experience, a quiet, alien beauty at the close of a Martian day. Saturn's moon, Enceladus, has a global ocean under its ice. The plumes of water vapor and ice crystals erupting from the south pole of Enceladus were one of the most spectacular discoveries of the Cassini mission. We now know they originate from a global salty ocean trapped between the moon's rocky core and its icy crust. The ocean is kept liquid by the tidal heating from Saturn's gravity, which flexes and warms the little moon's interior. The plumes contain not just water, but simple organic compounds, salts, and evidence of hydrothermal vents on the seafloor. Enceladus has all the key ingredients for life as we know it: water, chemistry, and a source of energy. It is one of the most promising places to look for life beyond Earth. Jupiter has no solid surface. The king of planets is a world without a foundation. It is a gas giant, composed mostly of hydrogen and helium. As you descend from its cloud tops, the gas gradually thickens, turning into a hot, dense fluid, and eventually, deep inside, into a bizarre, metallic form of hydrogen under unimaginable pressure. There is no distinct boundary between atmosphere and surface. Any probe sent into Jupiter would be crushed and melted long before it hit anything solid. It is a vast, swirling sphere of fluid, a dynamic, storm-jam-racked world that is more like a star that never ignited than a terrestrial planet. There is a region of space filled with icy bodies beyond Neptune called the Kuiper Belt. The solar system does not end with Neptune. Stretching outwards is a vast disk-jan-shaped region known as the Kuiper Belt, filled with countless icy bodies, including dwarf planets like Pluto, Haumea, and Makemake. This is the source of many short Jan period comets. The Kuiper Belt is a fossilized remnant of the solar system's formation, a deep Jan freeze that has preserved the original building blocks of the outer planets for over 4 billion years. It is our solar system's attic, filled with ancient, icy relics. The sun's magnetic field creates a vast protective bubble called the heliosphere. The sun doesn't just emit light, it constantly blows out a stream of charged particles called the solar wind. This wind inflates a giant protective magnetic bubble around our entire solar system. Known as the heliosphere, this bubble acts as a shield, deflecting a significant portion of the harmful galactic cosmic radiation that travels between the stars. We are all living inside this vast, invisible structure, sailing through the galaxy protected by our star's energetic breath. Pluto has a heart-jan-shaped glacier. When the New Horizons spacecraft flew past Pluto in Ardeen Yawu, it revealed a world of stunning and unexpected complexity. The most iconic feature is a vast heart-jan-shaped plain of nitrogen, ice called Tumbo Regio. The left ventricle of this heart, Sputnik Planitia, is a smooth, frozen basin without a single crater, indicating it is geologically young. The ice here is not rigid, it flows slowly like a glacier on Earth, convecting and renewing the surface. This frozen heart is a dynamic, active geological feature on a small, cold world billions of miles from the Sun, a symbol of the surprising vitality found in the most remote places. ID's rotation is slowing down. IT, the length of an Earth day is not constant. It is very gradually getting longer. The primary cause is the gravitational pull of the Moon, which creates tides in not just our oceans, but in the solid body of the Earth itself. This tidal friction acts as a very gentle brake, slowing our planet's spin. The effect is tiny a day gets about 1,000 milliseconds longer per century, but over billions of years it adds up. In the distant past, days were significantly shorter. This is a slow cosmic rhythm, a gradual unwinding measured over the lifetime of a planet. Mars has 2 moons, Phobos and Deimos, that are likely captured asteroids. Unlike our single, large moon, Mars has 2 small, lumpy, and cratered companions. Phobos and Deimos. They look more like potatoes than spherical moons. Their appearance and composition strongly suggest they are asteroids that were captured by Mars's gravity long ago, perhaps from the nearby asteroid belt. Phobos, the larger and closer one, is gradually spiraling inward due to tidal forces and will either crash into Mars or be torn apart to form a ring around the planet in tens of millions of years. They are transient, captured wanderers, temporary companions to the red planet. The Sun will eventually become a red giant. In about 5 billion years, the Sun will exhaust the hydrogen fuel in its core. It will then begin to burn helium, causing its outer layers to expand dramatically. It will swell into a red giant, a star so large that its outer atmosphere will engulf the orbits of Mercury, Venus, and likely Earth. Our world, if it still exists, will be incinerated. This is the inevitable fate of our star, a distant but certain future that marks the end of the solar system as we know it. It is a reminder of the transience of all things, even stars and planets on cosmic timescales. There is a dwarf planet in the Kuiper Belt called Haumea that spins incredibly fast and is shaped like a football. Haumea is one of the strangest worlds we know. It is a dwarf planet, but it is not round. It spins so rapidly, completing one rotation in less than 4 hours, that it has been stretched into an elongated ellipsoid shape, like a flattened football or a river stone. It also has a ring system and 2 small moons. This bizarre configuration is likely the result of a giant impact in its past that set it spinning wildly and created its moons and rings. It is a tumbling, distorted world on the fringe of our solar system. The planet Venus has a super-Jan rotating atmosphere, while Venus itself rotates incredibly slowly, taking Arbasus and Earth days to complete one spin. Its thick atmosphere whips around the planet at astonishing speeds. High Jan altitude winds can circle the entire planet in just about 4 Earth days, a phenomenon known as super-Jan rotation. This means the winds on Venus are vastly faster than the planet's rotation itself. The cause of this is not fully understood, but it creates a permanent, global hurricane in the cloud tops. A storm that has raged for millennia, utterly detached from the slow turn of the world below. Some comets are called sun grazers because they pass incredibly close to the sun. A family of comets, known as the Kreutz sun grazers, have orbits that take them perilously close to the solar surface. Many of these comets do not survive the encounter. They vaporize in the intense heat or are torn apart by tidal forces. The SOHO spacecraft has observed thousands of these comets diving towards their doom. They are ephemeral visitors, making a final, brilliant plunge into the fires of our star. A dramatic end to their long journey from the outer solar system. The planet Mercury has a very large iron core. Mercury is a planet of extremes, and one of its most puzzling features is its enormous core. The metallic core makes up about 5% of the planet's radius, a far greater fraction than for Earth. Venus, or Mars. One leading theory is that a massive collision with another protoplanet in the early solar system stripped away much of Mercury's original rocky mantle, leaving behind the dense metal gem-rich core we see today. It is a world stripped to its essence, a metal heart with a thin, rocky shell. There is a layer of Earth's upper atmosphere called the ionosphere that reflects radio waves. The ionosphere is a region of the atmosphere, between about Wushu and Liu Yungli less in altitude, that is ionized by solar radiation. This means it contains a high concentration of ions and free electrons. This electrically charged layer has the useful property of reflecting certain radio frequencies. This allows for long-Jan distance radio communication, as the signals can bounce between the ionosphere and the Earth's surface, traveling beyond the horizon. It is a natural global mirror for human communication, a gift from the interaction of our Sun and our atmosphere. The Moon is moving away from Earth at about the speed your fingernails grow. Due to the tidal interactions between Earth and the Moon, our lunar companion is slowly receding from us. The rate is about 10 centimeters inches per year. This is roughly the same speed at which human fingernails grow. It is a slow, imperceptible drift, but over hundreds of millions of years, it has a profound effect. In the distant past, the Moon was closer, appeared larger in the sky, and Earth days were shorter. Our relationship with our closest celestial neighbor is one of gradual, gentle separation. The planet Jupiter emits powerful natural radio waves. Sign Jupiter's immense magnetic field, the strongest of any planet, does more than just create auroras. It generates powerful radio waves, which can be detected by radio telescopes on Earth. These emissions are caused by charged particles, often from its volcanic moon Io, being accelerated along Jupiter's magnetic field lines. The sounds, if converted to audio, are eerie and haunting, like cosmic whistles and static. Jupiter is not a silent world. It is a source of constant, invisible radio songs, a symphony of magnetism and plasma. There is a theory that the solar system has a hidden planet 9 far beyond Pluto. astronomers studying the orbits of small, distant objects in the Kuiper belt have noticed that some of them cluster in a way that suggests they are being shepherded by the gravity of a large, unseen planet. This hypothetical world, dubbed Planet 9, is estimated to be about 5 to 10 times the mass of Earth and orbit hundreds of times farther from the Sun than we do. Its existence is still theoretical, and it has not yet been directly observed. The search continues for this potential ghost planet, a hidden giant that could redefine the known boundaries of our solar system. Fu. The Sun has an Shi-Jian-year activity cycle. Wu. The Sun is not a constant, unchanging ball of fire. It goes through a roughly Shi-Jian-year cycle of activity, marked by the number of sunspots on its surface. At solar maximum, the Sun is freckled with sunspots, and solar flares and coronal mass ejections are common. At solar minimum, the Sun's face can be blank for weeks. This cycle is driven by the winding up and eventual reset of the Sun's internal magnetic field. It is the heartbeat of our star, a slow, powerful pulse that influences space weather throughout the solar system. The planet Saturn is less dense than water. This is a classic, almost unbelievable fact. Saturn has an average density of about 0.6 grams per cubic centimeter, while water is 1.1. This means that if you could find a bathtub large enough, Saturn would float. This is because Saturn is composed primarily of the lightest elements, hydrogen and helium, and its immense volume is mostly empty space between gas molecules. It is a giant, puffy world, a cosmic balloon. There is a type of aurora on Mars. Even though Mars has a very weak global magnetic field, it does have localized magnetic fields frozen into its crust in certain regions. When charged particles from the solar wind interact with these magnetic umbrellas, they can excite atoms in the thin Martian atmosphere, causing them to glow. The ESA's Trace Gas Orbiter has detected a faint, diffuse green glow in the Martian night sky, an aurora that spreads across the entire planet, unlike the concentrated auroral ovals of Earth. It is a subtle, planet-gen-wide light show on a cold, desert world. The Oort cloud is a theoretical shell of icy bodies surrounding the solar system. Far beyond, the Kuiper belt, extending perhaps a light-year from the Sun, lies the Oort cloud. This is a hypothetical, spherical reservoir of trillions of icy objects, the source of long-Jan period comets that take thousands or millions of years to orbit the Sun. No object in the Oort cloud has ever been directly observed. Its existence is inferred from the orbits of these comets. It represents the true outermost gravitational boundary of the solar system, a vast, dark, and silent frontier. For planet Uranus has rings. While Saturn's rings are brilliant and iconic, Uranus also possesses a ring system. Its rings are very dark, narrow, and composed of likely charcoals and dark chunks of water ice and radiations and processed organic material. They were discovered in 1977 小时. And astronomers observed a star wink out briefly as the rings passed in front of it. The rings of Uranus are aligned with the planet's extreme tilt, so they appear to circle it vertically from our perspective. They are a subtle, dark, and elegant complement to the pale blue, sideways world. Light from the nearest star system, Alpha Centauri, takes over 4 years to reach us. The scale of interstellar space is humbling. The light from our Sun takes minutes or hours to reach the planets, but the light from the next nearest star system takes over 4 years to travel the void. When you look at Alpha Centauri in the night sky, you are seeing it not as it is now, but as it was over 4 years ago. Every star we see is a glimpse into the past, a fossil of light traveling across the gulf of space and time. There is a layer in Jupiter's atmosphere where the pressure is so high that gases turn into a liquid. As you descend into Jupiter's atmosphere, the pressure increases dramatically. At a certain depth, the hydrogen gas is compressed so much that it undergoes a phase transition, turning into a liquid. This is not a conventional liquid like water, but a sea of liquid metallic hydrogen. This exotic substance is an excellent conductor of electricity, and its motion is what generates Jupiter's powerful magnetic field. It is a world where familiar gases become alien oceans under the immense weight of the atmosphere itself. Fifth, the planet Earth has a second moon called a quasi-Jan satellite. Earth's gravitational influence doesn't just hold our large moon. A small asteroid named Seleujo Aryaoju Kamoroala is in a stable co-Jan orbital configuration with Earth. It is not in orbit around Earth like the Moon. Instead, it orbits the Sun in a path that keeps it consistently near our planet, making it appear to orbit Earth from our perspective. It is a quasi-Jan satellite, a tiny, distant companion that dances a complex gravitational dance with us around the Sun. The surface of Venus is covered in volcanic features. Radar mapping missions have revealed that Venus is a world dominated by volcanism. It has more volcanoes than any other planet in the solar system, over Ichen major ones, and countless smaller ones. It has vast lava plains, enormous shield volcanoes, and strange, pancake-Jan-like domes called pancake domes formed by viscous lava. While it is unclear if any are active today, the sheer number suggests a planet that was, and may still be geologically alive with fire, a stark contrast to its stagnant, cloud-Jan shrouded surface. The planet Neptune was the first planet discovered through mathematics. Uranus was found by telescope, but its orbit had slight irregularities. In the Ichen Babai Sushumil, mathematicians Urbain Leverrier and John Couch Adams independently used these wobbles to predict the position and mass of an unseen planet whose gravity was perturbing Uranus. When astronomers pointed their telescopes to the predicted spot in Ibas Salil, they found Neptune. It was a triumph of human intellect, a world found not by chance, but by the power of calculation and the laws of physics. There is a type of rock on the Moon called creep. Lunar rocks brought back by the Apollo missions revealed a unique type of basalt enriched in potassium. Rare earth elements Re and phosphorus P. This creep rock is thought to represent the last dregs of the lunar magma ocean to crystallize, meaning it contains elements that didn't fit into the common minerals that formed the Moon's early crust and mantle. It is a geochemical fingerprint of the Moon's violent and molten birth. The Sun's outer atmosphere, the corona, is much hotter than its surface. The Sunkti, one of the most enduring mysteries in solar science, is the coronal heating problem. The Sun's visible surface, the photosphere, has a temperature of about Wutsen Wubai Shushadu. Yet, the outer atmosphere, the corona, blazes at over 1 million degrees Celsius. How energy is transported from the cooler surface to the superheated corona is not fully understood, though it is likely related to the Sun's complex and dynamic magnetic field. It is as if the air around a fireplace were thousands of times hotter than the fire itself. The planet Mars has the largest dust storms in the solar system. Firsin, Mars is a desert world, and its thin atmosphere can generate colossal dust storms. These can start as a local gust and within weeks grow to envelop the entire planet. The dust is so fine that it can stay suspended for months, turning the sky a hazy pink and blocking sunlight from reaching the surface. These global storms can radically alter the planet's climate for a season and have been the end of solar Jan-powered rovers. It is a world that can be consumed by its own rusty soil. There is a moon of Saturn, Iapetus, with a giant equatorial ridge. Iapetus is a 2-Jan-toned moon, with one hemisphere significantly darker than the other. But its strangest feature is a massive ridge that runs along its equator, stretching over Babai Yingli less long and up to Shah Yingli less high. In places, it looks like the seam of a walnut. Its origin is unknown, but theories include the collapse of a former ring system onto the surface, or internal forces that squeeze the moon at its equator. It is a bizarre and prominent feature on a distant, icy world. The planet Earth is not a perfect sphere. Due to its rotation, Earth bulges slightly at the equator and is flattened at the poles. This shape is called an oblate spheroid. The difference is small. The polar diameter is about 60 kilometers, less than the equatorial diameter. But it is measurable. This bulge means that you are slightly farther from the center of the Earth at the equator than you are at the poles. Our planet is a gently squashed ball, shaped by the centrifugal force of its own spin. Some asteroids are binary systems, two rocks orbiting each other. A significant number of asteroids are not single bodies, but two similarly Jan-sized objects orbiting a common center of gravity. These binary asteroids are thought to form through various processes, including the gentle collision and capture of two bodies, or when a fast Jan-spinning asteroid flings material off its equator that coalesces into a moon. The first one discovered was Ida and its moon Dactyl. They are silent, dancing couples in the dark, bound by a weak but persistent gravitational embrace. The planet Venus may have had oceans in its distant past. Climate models suggest that billions of years ago, Venus may have been a much more temperate world, with liquid water oceans on its surface. A runaway greenhouse effect, perhaps triggered by increased solar radiation or massive volcanic outgassing, eventually evaporated these oceans. The water vapor, a potent greenhouse gas itself, trapped more and more heat, leading to the scorching, hellish conditions we see today. Venus is a stark warning of how a planet's climate can be pushed to an extreme, a possible vision of a future Earth if our own climate is not carefully stewarded. The planet Jupiter has a faint ring system. Discovered by the Voyager ES spacecraft, in Ijozito, Jupiter's rings are dark and tenuous, made mostly of small dust particles. Unlike Saturn's bright ice rings, Jupiter's rings are likely composed of dust knocked off its small inner moons by micrometeorite impacts. The main ring is broad and flat, and there is also a donut-Jan-shaped halo ring interior to it. They are a subtle, dusty shroud around the giant planet. There is a type of meteorite called a palisite that looks like stained glass. Palisites are among the most beautiful objects in the solar system. They are stony Jan-iron meteorites that consist of olivine crystals, a beautiful greenish mineral embedded in a metallic nickel Jan-iron matrix. When sliced thin and polished, they look like cosmic stained Jan glass windows. They are thought to come from the boundary layer between the metallic core and the rocky mantle of a differentiated asteroid that was shattered in a collision. They are literal pieces of a broken world's heart. The planet Mercury has a comet Jan-like tail. Like our moon, Mercury has a tenuous exosphere, and sodium atoms within it are pushed by solar radiation pressure to form a faint yellow tail that streams away from the sun. This tail can be millions of miles long and is detectable from Earth with sensitive instruments. It is a world so close to the sun that it is constantly being blown by the solar wind, leaving a faint ethereal signature in its wake. The planet Saturn's moon, Titan, has sand dunes made of plastic. Titan's dunes are not made of silicate sand like on Earth. Radar data from Cassini revealed that they are composed of dark, organic hydrocarbons that precipitate out of the hazy atmosphere. These particles, about the size of sand grains, are likely made of complex plastics. Vast fields of these dunes shaped by wind stretch across Titan's equatorial regions. It is a world with familiar geological features, but constructed from utterly alien and strangely familiar materials. For their sun is traveling through a local cloud of interstellar gas. Our solar system is not moving through a perfect vacuum. We are currently passing through a region of slightly denser interstellar gas and dust known as the local interstellar cloud. Lick, the sun's heliosphere, pushes against this cloud as we move through it at about 10,000 公里. This local environment can influence the shape and size of the heliosphere. We are sailing through a gentle, galactic breeze Thovi. The planet Mars has polar ice caps made of water and dry ice. Mars has bright white caps at its north and south poles. These are not just made of water ice, like on Earth. During the Martian winter, the poles are so cold that carbon dioxide from the atmosphere freezes directly onto the surface as dry ice, adding a thick layer of frozen hoar. In the summer, this dry ice sublimates back into the atmosphere, leaving behind a permanent, much smaller cap of water ice. It is a world with seasons of frost and thaw, written in two different kinds of ice. There is a gap in the asteroid belt called the Kirkwood Gap. The asteroid belt is not a uniform smear of rocks. There are distinct regions where very few asteroids are found. These Kirkwood gaps are caused by orbital resonances with Jupiter. An asteroid in one of these orbits would be gravitationally nudged by Jupiter repeatedly at the same point in its orbit, like being pushed on a swing in rhythm. Over time, these repeated kicks eject the asteroid from that orbit, clearing a gap. It is a visible signature of Jupiter's powerful and ordering gravitational influence. The planet Earth's magnetic poles can flip. The Earth's magnetic field is not constant. Periodically, the north and south magnetic poles reverse places. The last reversal happened about 7,000 years ago. The process is not instantaneous. It takes thousands of years during which the field weakens and becomes complex. Evidence for these reversals is preserved in the magnetic orientation of ancient volcanic rocks on the seafloor. Our protective magnetic shield is a dynamic, living thing with a history of dramatic change. The planet Uranus is named after the Greek god of the sky, while all the other planets are named after Roman gods. This is a small point of celestial trivia. Jupiter, Saturn, Mars, Venus, and Mercury are all named for Roman deities. When Uranus was discovered, the tradition was continued, but the astronomer William Herschel initially wanted to name it Georgium Sidus, George's star after his king. Fortunately, the classical name Uranus, the Greek personification of the sky and father of Saturn, Cronus, won out, preserving a mythological consistency, albeit from the Greek pantheon. There is a type of aurora on Jupiter that is only visible in ultraviolet light. Jupiter has the most powerful auroras in the solar system, generated by particles from both the solar wind and its volcanic moon Io. Some of these auroras, particularly those linked to Io, are so energetic that they emit most of their light in the ultraviolet part of the spectrum, invisible to human eyes. To our sight, they would be a dim, deep red, but in UV images, they are brilliant, dancing halos of incredible energy around the planet's poles. The planet Venus has a double vortex at its south pole. Observations by the Venus Express spacecraft revealed a massive, persistent double Zen vortex storm swirling over the planet's south pole. It is a complex, changing structure, like a giant figure Zen 8 or in shape, that sits atop the pole, a permanent hurricane born from the planet's super-Zen rotating atmosphere. It is a stable, yet dynamic, whirlwind in the toxic clouds of our sister planet. The sun's gravity bends the light from distant stars. This is a prediction of Einstein's theory of general relativity. The sun's mass warps the space around it, causing the path of light from stars behind it to curve. This effect, called gravitational lensing, was first confirmed during a solar eclipse in 1919 小时, and stars near the sun's edge appeared slightly out of position. It was a pivotal proof that mass could distort the very fabric of space-Zen time, a concept that now underpins our understanding of the cosmos. The planet Mars has gullies on its crater walls that may be formed by liquid water today. High Zen resolution images of the Martian surface reveal dark, narrow gullies that look strikingly similar to water Zen carved gullies on Earth. They appear to form and change seasonally. The exact mechanism is debated. It could be flows of briny, salty water that remains liquid at low temperatures, or flows of dry sand and dust. But the possibility that liquid water might still occasionally trickle down the slopes of Mars is a tantalizing one, suggesting the planet is not entirely dead. There is a dwarf planet named Sedna with an extremely elongated orbit. Discovered in Lansending Sen, Sedna is a large reddish object in the far outer solar system. Its orbit is incredibly eccentric, taking it from about 6 astronomical units, or from the Sun at its closest, to a staggering 9 AO at its farthest. A single orbit takes about 1,000 years. Its origin is a mystery. Its path is so far out that some scientists speculate it could have been perturbed by a passing star in the Sun's birth cluster, or even by the hypothetical planet 9. It is a lonely wanderer on a vast, cold and silent journey. The planet Earth has a geocorona, a vast cloud of hydrogen atoms extending far beyond the Moon. The outermost part of Earth's atmosphere, the exosphere, doesn't have a sharp boundary. It gradually fades into space, with a tenuous cloud of hydrogen atoms extending out to at least Yao-Li-Nun kilometers, well past the orbit of the Moon. This geocorona glows faintly in ultraviolet light as the hydrogen atoms scatter sunlight. Our atmosphere is far more extensive than it appears, a ghostly, spherical halo enveloping our world. The planet Saturn's moon, Hyperion, is a sponge Jan-like world. Hyperion is one of the most bizarre Jan-looking objects in the solar system. It is a small, potato Jan-shaped moon with a deeply pitted, spongy surface. Its density is very low, suggesting it is highly porous, perhaps up to 500 empty space. It is likely a rubble Jan-pile object that has undergone intense bombardment, with impacts compressing the surface into the strange honeycombed structure we see today. It is a cosmic sponge tumbling chaotically in its orbit. The Sun will not become a supernova. Only very massive stars end their lives in the cataclysmic explosions known as supernovae. Our Sun is not nearly massive enough. Its fate, as we've learned, is to become a red giant and then a white dwarf. It will end its life not with a bang, but with a long, slow cooling, eventually becoming a black dwarf, a cold, dark stellar ember. It is a gentle, if still dramatic, end for the star that gave us life. For the planet Jupiter's great red spot is shrinking. For centuries, the great red spot, a giant storm larger than Earth, has been a defining feature of Jupiter. But observations over the past several decades show it is steadily shrinking in size. While it is still a colossal tempest, its diameter has reduced significantly. The reasons are not fully understood, but it suggests that even the most enduring storms in the solar system are not permanent. It is a slow, quiet fading of a Jovian legend. There is a layer in Earth's atmosphere called the mesosphere, where meteors burn up. The mesosphere is the third layer of our atmosphere, situated above the stratosphere and below the thermosphere. It is here, about 2 to 2 kilometers, 10 to 2 les, above the ground, that most meteors encounter enough air resistance to vaporize, creating the brief, bright streaks we call shooting stars. The mesosphere is our planet's shield against the constant, gentle rain of cosmic dust and small rocks. The planet Neptune has a moon, Nereid, with one of the most eccentric orbits of any moon. A Nereid, one of Neptune's moons, follows a wildly elliptical path. Its distance from Neptune varies from about 10 lion kilometers to over 10 lion kilometers. This extreme orbit is another piece of evidence supporting the theory that Triton was captured, as the gravitational upheaval from that event could have flung Nereid into its strange, looping path. It is a moon on a long, lonely journey, swinging from close embrace to distant isolation. The solar system is moving towards the constellation Hercules. Our Sun, and with it the entire solar system, is not stationary in the galaxy. We are moving at about 18 kilometers per second around the galactic center. The point in the sky towards which we are heading is called the solar apex, and it lies in the constellation of Hercules. We are all, every one of us, on a grand voyage towards the hero of the stars. The planet Venus has snow made of heavy metals. On the high mountain tops of Venus, above the scorching plains, there is a strange reflective substance. It is not water snow, as the temperatures are still far too hot. Radar data suggests it could be a metallic, frost, composed of compounds like lead sulfide and bismuth sulfide. These minerals, vaporized on the lower, hotter plains, might condense and settle on the cooler highlands, creating a glittering metallic cap on the peaks of hell. It is a beautiful alien phenomenon in a hostile world. There is a region of the Kuiper Belt called the Scattered Disk. Beyond the main, relatively flat Kuiper Belt lies a sparser region known as the Scattered Disk. The objects here, like Eris, have highly inclined and eccentric orbits, suggesting they were scattered outward by gravitational interactions with Neptune during the solar system's early migration. This region is the source of many of the solar system's short sand period comets and represents a dynamic, unstable frontier. The planet Earth's core is about as hot as the surface of the Sun. The temperature at Earth's inner core, a solid ball of iron, jan-nickel alloy, is estimated to be about 5770度, 11300度, which is roughly the same temperature as the Sun's photosphere. This incredible heat comes from the residual energy of planetary formation, the friction of dense material sinking to the center, and the decay of radioactive elements. Our planet has a miniature star's worth of heat burning at its heart, driving the geology that shapes our world. The planet Mars has a valley called Nergal Vallis that looks like a branching river network on Earth. Nergal Vallis is a long, branching valley on Mars that bears a striking resemblance to a dried Janup River valley on Earth. Its pattern suggests it was carved by flowing water, likely in the distant past when Mars was warmer and wetter. It is a ghost of a river, a silent, sandy testament to a time when water may have flowed freely on the red planet. The Sun is a populationized star. Astronomers classify stars into populations based on their metallicity, the fraction of elements heavier than hydrogen and helium. Population-ized stars, like our Sun, are metal-gen-rich and are found in the disks of spiral galaxies. They are generally younger stars, formed from the recycled material of earlier generations of stars. Our Sun is a product of cosmic recycling, its composition enriched by the lives and deaths of stars that came before. For the planet Jupiter's moon, Europa, has a very smooth surface. Unlike our heavily cratered moon, Europa's surface is remarkably smooth. It is a global landscape of cracked and jumbled ice, with very few large impact craters. This indicates that the surface is geologically young, constantly being renewed by processes from below. The ice crust is likely a dynamic shell, shifting, cracking, and refreezing over the hidden ocean, erasing the scars of ancient impacts. There is a type of rock on Earth called a tektite, which is glass formed by meteorite impacts. When a large meteorite strikes the Earth, the immense heat and pressure can melt the target rock and fling it high into the atmosphere. This material cools and solidifies in flight, falling back to Earth as beautiful, often aerodynamic, shapes of natural glass called tektites. They are not meteorites themselves, but terrestrial rocks transformed by an extraterrestrial event. They are frozen splashes of a cosmic collision. The planet Saturn's moon, Rhea, was once thought to have a ring system. 3D data from the Cassini spacecraft initially suggested that Rhea, Saturn's second and largest moon, might have a faint ring of its own. This would have been the first known ring around a moon. However, more detailed observations failed to confirm the rings. The original data was likely caused by a temporary cloud of dust and debris surrounding the moon. It was a fleeting, unconfirmed possibility of a moon with its own set of rings. The solar system is tilted relative to the plane of the Milky Way galaxy. The ecliptic plane, in which the planets orbit the Sun, is not aligned with the galactic plane. It is tilted at an angle of about Lucia degrees. This means that as we orbit the Sun, and the Sun orbits the galaxy, our perspective of the Milky Way's disk changes throughout the year. We are not flat with the galaxy, but cocked at a significant angle, giving us a unique, changing view of the stellar city we call home. When the planet Mercury has hollows, messenger spacecraft images revealed strange, bright, irregular depressions on Mercury's surface called hollows. They are not impact craters. They appear to be areas where volatile material has sublimated away, causing the ground to collapse. They are geologically young and suggest that Mercury's surface is still evolving in unexpected ways, even without an atmosphere or plate tectonics. There is a point in space where the gravitational pull of the Earth and Moon cancel out, called a Lagrange point. The Earth-Moon system has 5 Lagrange points, positions in space where the combined gravitational pull of the two bodies provides the precise centripetal force required for a small object to orbit with them. The LE point, for instance, lies between the Earth and Moon. These points are like gravitational eddies, stable parking spots in space that are useful for satellites and future space stations. The planet Venus has a circular orbit. Of all the planets, Venus has the orbit that is closest to a perfect circle, with an eccentricity of only Lin-Dan-Lin-Chi. Earth's orbit is slightly more elliptical, eccentricity Lin-Dan-Lin-Chi, and Mercury's is much more so Lin-Dan-Arlin-Wu. Venus follows an almost perfectly round path around the Sun, a model of circular perfection in a solar system of gentle ellipses. The Sun's magnetic field is twisted and complex. The Sun's magnetic field is not a simple, orderly bar magnet, because the Sun is a ball of gas. Different latitudes rotate at different speeds, differential rotation, which winds up and tangles the magnetic field lines over the Shi-Jian-Ye cycle. This twisting stores immense energy, which is released in the form of sunspots, solar flares, and coronal mass ejections. The Sun's magnetism is a dynamic tangled web of power. The planet Mars has a crust that is one piece. Unlike Earth's crust, which is broken into moving tectonic plates, Mars has a single, continuous lithosphere. This stagnant lid tectonics is one reason volcanoes like Olympus Mons could grow so immense. The volcanic hotspot remained fixed under the same spot in the crust for billions of years. It is a world with a unified global shell. There is a type of variable star called a Cepheid that is used as a standard candle to measure distances in the universe. While not in our solar system, the understanding of Cepheid variables was a key that unlocked the scale of the cosmos. These stars pulsate with a period that is directly related to their intrinsic brightness. By observing their period and apparent brightness, astronomers can calculate their distance with great accuracy. They were used by Edwin Hubble to prove that the spiral nebulae were actually other galaxies far beyond our own Milky Way. The planet Earth has a twin planet, but it is not Venus. In terms of size, mass, and composition, the planet most similar to Earth in our solar system is Venus. But in a broader sense, the search for Earth's twin now extends to exoplanets, orbiting other stars. Planets like Kepler-Gen-2b, which orbits a Sun-Gen-like star in its habitable zone, are considered Earth-Gen-like in certain key characteristics. The concept of a twin has expanded from our backyard to the galaxy at large. The solar system has a bow shock as it moves through the galaxy, just as a boat creates a bow wave as it moves through water. The Sun's heliosphere was thought to create a bow shock as it plows through the interstellar medium. However, recent data from the IBEX spacecraft suggests the Sun's speed through the local cloud may be too slow to form a true shock wave. Instead, there may be a more gentle bow wave. It is a subtle point of interaction between our star and the galaxy. The planet Jupiter's moon, Callisto, has one of the most heavily cratered surfaces in the solar system. Callisto's surface is ancient. It is a dark, icy landscape that has been bombarded for billions of years, and it shows no signs of the geological activity that has resurfaced Europa or Ganymede. Its craters upon craters are a record of the early violent history of the solar system, preserved in deep freeze. It is a time capsule, a fossil world in orbit around a giant. There is a theory that the Moon was formed from a giant impact with a Mars-gen-sized body named Theia. The leading theory for the Moon's origin is the giant impact hypothesis. It proposes that early in Earth's history, a protoplanet roughly the size of Mars, nicknamed Theia, collided with the young Earth. The impact vaporized part of Earth's mantle and Theia, and the debris from this collision coalesced in orbit to form the Moon. This explains the Moon's similar isotopic composition to Earth's mantle and its lack of a large iron core. It was a birth of fire and chaos. The planet Saturn's moon, Pan, has a flying saucer shape. Pan is a small moon that orbits within the Encke gap in Saturn's ring. Its gravity clears that gap. Images from Cassini revealed that Pan has an unusual shape. A prominent, smooth equatorial ridge of accumulated ring material gives it the appearance of a cosmic ravioli or a flying saucer. It is a moon that has dressed itself in the finery of the rings it tends. The Sun's energy output is not perfectly constant. The Sun's total solar irradiance, the amount of energy it emits, varies slightly over the Shi-10-year solar cycle. The difference is only about 500 but this small variation can have subtle effects on Earth's upper atmosphere and climate. The Sun is a variable star, but its variations are, for now, gentle and predictable. A planet Neptune's moon, Proteus, is not round. Proteus is the second-gen largest moon of Neptune and one of the largest non-gen spherical objects in the solar system. It is a lumpy, cratered world, shaped more like a potato than a ball. It is not massive enough for its own gravity to have pulled it into a sphere. It is a rugged, primordial chunk of rock and ice. A testament to the diverse shapes of small worlds, there is a type of aurora on Saturn that is linked to its moon, Enceladus. The water vapor and ice particles, spewing from Enceladus's south pole, become ionized and are captured by Saturn's magnetic field. These particles are then funneled towards the planet's poles, where they interact with the atmosphere and create a faint but distinct auroral footprint. It is a direct, luminous connection between a moon and its planet, a beacon in the magnetic field triggered by a distant, icy geyser. The solar system is full of cosmic dust. In addition to planets, moons, and asteroids, the space between the planets is filled with a fine mist of microscopic dust particles. This interplanetary dust comes from comets, asteroid collisions, and even the interstellar medium. It is this dust that causes the faint glow in the sky after sunset known as the zodiacal light. We are constantly gently being dusted with the finest powder of creation. The planet Earth is the only world we know of that has fire. Fire is a rapid oxidation process. It requires fuel, heat, and an oxidizer like the oxygen in our atmosphere. While other worlds may have volcanic fires or atmospheric lightning, Earth is the only planet known to have the precise combination of a nitrogen-oxygen atmosphere and widespread combustible materials, like plants, to support open flame. The dancing of fire is, for now, a uniquely terrestrial phenomenon. The planet Jupiter's radiation belts are dangerous to spacecraft. Jupiter's powerful magnetic field traps intense radiation, creating belts of energetic particles millions of times more powerful than Earth's Van Allen belts. This radiation is a major hazard for spacecraft electronics and instruments. The Galileo probe, which orbited Jupiter, had to be specially hardened to survive. And even so, it sustained significant radiation damage over its mission. To visit Jupiter is to brave an invisible storm of atomic particles. There is a layer in the Sun called the tachocline. The tachocline is a thin, transitional layer between the Sun's radiative zone and its convective zone. It is here that the Sun's rigid Jan body rotation of the interior gives way to the differential rotation of the exterior. This layer is thought to be the seat of the solar dynamo, where the Sun's magnetic field is generated. It is a crucial hidden engine room of our star. The planet Mars has a mineral called olivine in its soil. On the Mars, rovers have identified the mineral olivine in Martian rocks and soil. Olivine is a silicate mineral that weathers quickly in the presence of water. Its widespread presence on the surface of Mars suggests that the planet has been dry for a very long time, as liquid water would have turned the olivine into other clay minerals. It is a mineralogical clue to the long, arid history of the red planet. The solar system is surrounded by a vast theoretical shell of comets called the Oort cloud. As we drift to a close, we return to the deepest, darkest frontier. The Oort cloud is a hypothetical, spherical cloud of icy planetesimals believed to surround the Sun at distances ranging from Laochen to Yalin-Dindin astronomical units. It is the source of long Jian period comets. No object in the Oort cloud has ever been directly observed. Its existence is a necessary inference, a final, vast, and silent reservoir at the very edge of the Sun's gravitational dominion. It is the true end of our journey, the final whispering thought before sleep. And so our quiet spiral through the solar system comes to its gentle end. We've drifted past worlds of fire and ice, through silent storms and ancient valleys, and out to the very edge of light's memory. The facts and figures can fade now, leaving only the feeling of wonder, the sense of a vast, beautiful, and peaceful cosmos. Let your breathing be slow, your body light. You have traveled far without moving, and the universe is content to let you rest. The stars will keep their watch. There is no need to hold on to anything. Just let go and drift into the quiet. Thank you for wandering with me. I hope you sleep deeply and dream of floating peacefully among the silent, turning worlds. Good night.